Hello, everybody. Welcome back to Planet X News. This is Scott from the Nibiru channel. It is May 22nd, 2017. We are back here with our physicist, and we're going to be talking about a lot of things in this broadcast. First and foremost, the doctor has written two reports that we're going to be going over, and one of the reports has to do with the photographs of that large blue planetary object that I photographed back in the beginning of May. We've now found out that several other people have photographed this object. The clearer photographs were taken by me, but we do know that this object definitely exists. But first, before we start this broadcast, I want to touch on a few subjects. And one of the first subjects I want to touch on is of a personal matter. You know, after we ended the last broadcast, I guess I hate to even mention their names, but the trolls started sending me emails and making absolutely filthy comments about the doctor and in general about women. And I don't know if they were trying to get under my skin, but this time it did get under my skin. They basically said that the doctor has no business teaching and women shouldn't be in certain areas of employment. Well, I'm going to have to beg to differ, because my mother went through the same thing, not as dramatic as what is happening to the doctor now, but my mother was a single mother, raising me and doing the best that she could and working two jobs and going to college, and then later on getting her master's degree. And I remember many, many conversations that my mother was having with my grandmother about how hard things were on her and how things were being a woman in a man's world. And I remember these conversations as a very young child. And whenever people are making these very, very rude comments about women in the workplace, well, just let me tell you firsthand, I don't believe in any of that nonsense. I believe that women can do anything that men can do. I know from my own work experience, working with women in many different facets, there is no line. There is no fine line. We're all human beings. We can all be trained. We all have a brain, and we can do anything that we want to do. And I remember a case, just a few years ago. I was working on a major casino development project, and naturally, we were in charge of excavating all of the land for this massive casino to be built. And we needed some extra workers. So the union sent a beautiful, young, blonde-haired lady that was fresh out of heavy equipment operations school, 24 years old. Now she was going to be cast into the limelight, as we say, and she was going to be running a massive excavator on this project. Well, the guys weren't going to have it. They harassed her over the CB, the radio, constantly for 12 hours a day. And the supervisor actually kind of did the same thing. You would think after a week of this nonsense that this young lady would quit and move on to another job, but she didn't. And she ended up turning out to be one of the best and one of the smoothest excavator operators that I've ever worked with in heavy machinery operation. But after learning the ropes on our crew and, well, basically putting up with a lot of nonsense, she, as they say, earned the respect of the guys on the crew. Well, that shouldn't happen in today's life. It is 2017, not 1930. And for some of the comments that I read from some of these ignorant individuals pertaining to women in the workplace and professional women, I just thought it was super ignorant. Because one day, you never know when you may be laying on an emergency room table, bleeding to death or dying, and the doctor or surgeon standing over you is a woman. A surgeon, a doctor. And the same applies for our doctor and our physicist, and she should be commended for all of her academical achievements, of which none of these others have even dreamed about achievements like this. So I just wanted to get that right off of my chest, because the emails and the comments that I received after our last broadcast actually turned my stomach and made me sick. But anyways, there is another subject matter that we are going to enter into. I've been receiving some emails from Steve Olson over at WSO. And I just received an email from him just after the last broadcast, basically saying that we're perpetrating a fraud. And we're going to go back into a little bit of history with Mr. Steve Olson and the doctor and her writing these papers, because there is no fraud here. There is no fraud whatsoever. The termination process at the university started immediately whenever they relieved the doctor of her lecturing. It wasn't a solid termination because she knew that she had a union and she started to take the course of fighting back. So please, everyone, understand that. But there are others out there that like to twist words and turn things around. But now, all of a sudden, a few days ago, I was watching a live stream that was put together by one of these trolling channels on YouTube. And towards the end, I see the likes of this notorious Dazza the cameraman, Astronomy Live, and several others in the live chat talking it up, blah, 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 blah. And then the next thing I know, I see the logo of the YouTube channel WSO coming in there and commenting and laughing, and seem to be having a good time with the likes of these troll monsters. Even going as far as telling them, I love you. I have all of the screenshots. I was absolutely appalled and sickened by what I saw and what I was hearing within their stupid little broadcast. A few days after, I referred to Mr. Olson as a mole, meaning, you know what a mole is? That little rodent that kind of burrows its way in. Well, that's what it seemed like he was doing. He was burrowing his way in with the trolls so they leave him alone, complimenting them, even going as far as telling one of the individuals who has a few singing videos on his channel that he loves his voice. And this was one of the guys that infiltrated his YouTube channel as a guest for months and then turned on Steve like a wild rabid dog. And now you're going to tell this man that you love his voice and you love his singing? Well, what a better way to kiss someone's ass. Back in November of 2016, when these notorious individuals took down WSO, took down the channel, suspended it from YouTube, the first person that came to Steve's rescue was me. And I helped him. I helped him for the entire time that his channel was suspended. Shortly afterwards, I never heard from him again. till we did one other live stream with several other Planet X researchers. And then again, from that point, never heard from him again. So we are the actual ones. We are the ones that are perpetrating a fraud, when in fact, for the last year, these notorious scumbags have gone after WSO, telling everyone that he was the one perpetrating a fraud because he was taking donations for an imaginary online ministry, basically using religion and God for donations. This was their ploy. I defended the man over and over and over again. But that's not going to happen anymore. And now we come to find out that when the doctor was originally working with Steve's channel and writing papers, he was barely using them, barely acknowledging the information, as she worked very hard to uncover this research. And then we come to find out that his new website that you pay to be a member of, he has made all of this information, all of her research papers, he's made them public and for sale, basically. And the doctor never intended for her personal research papers to be on the open market for sale. But apparently, the YouTube channel WSO has taken upon themselves to, I guess, provide a Google Drive link to the doctor's papers and research papers that were written without her permission. You know, it would have been different if you would have said, hey, do you mind if I put these up on my website? We discussed this some time ago, and we decided that this wouldn't be a good idea because the trolling factions would take the information, change it, and then create all of their stupid videos and create even more disinformation. So the fact of the matter is that the YouTube channel WSO allowed trolls to infiltrate his organization not once, but twice. And they tried to take him down, and then they succeeded. He got back up on his feet. But now it seems that he's possibly dancing to a different tune. But to call any of us a fraud is a slap in the face. I will not return these emails. I will not answer these emails. And as far as I'm concerned, that channel of WSO is dead. It doesn't exist to me. No valuable information is coming out of that channel. Not even the ridiculous GNN YouTube channel that was created as basically backup revenue. More donations, more contributions, more science projects, more balloons into the atmosphere. A few months ago, the rumor was being passed around by whatever factions that there was some type of recovery agent looking for Mr. Steve Olson because he had stolen $150,000 from a church organization for the purchase of bunkers in the Ozarks. I don't know how much truth there is to that. I have no knowledge of it. I wasn't privy to the information. I'm just going by what was out there. And this went on for months. I guess the story died out. But for other YouTube channels researching the same subject to come on board and just call us frauds after you actually worked with the doctor in a sort of a way, and now you're exploiting her research papers for monetary gain. Slap in the face. So anyways, doctor, once again, good afternoon. How are you?
Good afternoon, Scott. I'm fine, thank you. And you?
I'm doing pretty good. I'm a little heated right now at that last email that Steve Olson sent me. But, you know, I mean, I just want to, I don't want to go into this real far, but, you know, in the beginning, you initially did you initially contact Steve?
I did,
pertaining
Scott.
to research?
Yes, I did. In the beginning, I started trying to help him out. And I worked with him and Wayne. And yeah, specifically Wayne, I really liked. He was very nice to me. And yeah, so I worked with him for a while, and then I started working with Chris as well. And now Chris was always very careful. He refused to always put out my papers or give them to anybody because they had metadata on them, because I didn't know how to remove my metadata. But Steve, well, this is how my information got leaked, because Steve gave one of these papers to someone. And this woman found my, who I was. I don't know if she was a troll or not. And she emailed me at work, and I never responded to that email. But, you know, later on I thought, but, you know, Steve was a computer expert, just like Chris is. So how come he didn't know about the metadata? Why wasn't he careful? And that question is still with me. Then later on, he started, when he did a video on one of my papers, he would offer it on a Google Drive. And this would make me feel uncomfortable. But I didn't say anything for a while. Eventually, I said to him, look, Steve, I'm uncomfortable with you offering my my papers on a Google Drive, because someone has actually managed to email me through one of those papers. So I don't know what happened after that, but that's when the email started from Astronomy Live. So that's when I guess they realized that was my email address or something. So I believe it was either on purpose or through just neglect that Steve leaked my information. And so that's why I actually decided not to work with him. Because on top of that, I was sending him papers that I had written, and he was refusing to make videos on them. And it was only Chris doing these videos, and the trolls were really putting a lot of pressure on Chris. And I thought, no, I need someone else to help with this work. And that's when we started working together. So, I mean, I was never going to say anything about Steve and the fact that I believe that he leaked my information. And that's why I stopped working with him. But I see now that he's accusing you of doing that. So I think I have to set the record straight.
Yes, please do, because at this point in time, you know, right after we got finished with our other live stream, I wasn't, you know, 5-10 minutes later, I get the email, and, you know, I could expose the email, and I can't expose all of the screenshots that I took of that live chat, which was one of the most notorious trolling channels on YouTube, who caused, I mean, they were basically both of the individuals that made their way into his little organization and then screwed him and basically went turncoat, but that was the plan. And it's very, very confusing. And I don't know if this is one big, massive charade and one big game, but I'm not down with the game. That much is a fact. And removing metadata for a person who is a so-called computer expert is a piece of cake. I can do it.
Yeah.
So I think there was some exploitation on his end. And now to take all of those reference papers that you wrote and to have them up on his website that you have to pay to join, and basically he is selling your work.
Yes.
Yeah.
Okay. Yeah, well, in the beginning, I gave him
WSO
permission.
Fans. There you go, WSO fans. There you go.
Yeah. But in the beginning, I gave him permission to do that, but I told him to not offer my papers on Google Drive. And I think I will now make it very clear that I don't want my papers offered through his website anymore. Because, I mean, I don't make any money out of my own papers. I write them because I want people to know the truth. I'm not making money out of them. And now that he's accused you and everything, I don't think what he's doing is right. And I think I'm going to say to him specifically, I don't want you to use my papers anymore. Not at all.
I find this very disturbing because remember, me and you and Chris Potter, we had this conversation months ago because I have a website, and we talked about specifically, hey, should we put these documents up on the website so everybody can take a gander and look at them? And then we figured, we better not, because the trolling factions will copy the paperwork, change the words around, and basically make you look like a fool. So we came to that conclusion rather rapidly. And here we are, once again, just trying to shoot for the truth, do some research, do some investigation, help out our fellow man and woman, and in turn, the people that you tried to help turn around and shit right on the back of your neck.
Yeah.
Well, we're not going to have it. Plain and simple.
Thank you, Scott.
Fact of the matter is, I have the screenshots that I took the other night from that live stream hangout on YouTube, and I can't even look at them because they make me sick to see someone that was supposed to be on our side turncoat right over to the other side, kissing their feet, and also agreeing to do live streams with them at one point in the very near future. Ooh, I almost dropped an F-bomb right there. Sorry.
Oh my. Oh my.
I try to keep it clean. But anyways, we are going to go into this report that you've done. And it's a short report, but it is based on the photographs that I took. And they are pretty extraordinary photographs. After we got off the last live stream, I actually looked at my own photographs again, scrutinized them again, and other people around the world have been taking similar photographs. And the doctor has actually done some homework on this, and she's actually located some other YouTube videos that have come out recently, and they're pretty similar to mine. But we're going to go ahead and jump into this report. I'm going to go ahead and share our screen, and then I will turn it all over to you. And that's what we do. And here we have it.
Right.
Okay, Doc, all you need to do is whenever you need me to pan down for you, just let me know.
Okay, thank you, Scott. All right, so I start out by explaining what is known in the research on brown dwarfs. And that is brown dwarfs, they are defined to be, an object is defined to be a brown dwarf if it's substellar, that is, it's not fusing hydrogen into helium. And if it has a mass that is 13 times the mass of Jupiter, and up to 90 times the mass of Jupiter. Okay, although some papers will say up to 80 times, but I think I've seen some recent work where they mention 90 times. And the accepted value for the density of these objects is 70 grams per centimeter cubed. And if you use that value, then and use the range in mass from 13 to 90 times the mass of Jupiter, you get a radius range of between 0.6 times and 1.2 times the radius of Jupiter. So from that, you actually see that they will look smaller than Jupiter up to slightly larger than Jupiter from their radius. Now, the object that you photographed, if you look at it, so you just compare the size of it with the sun, you'll see that it's about 1/3 of the size of the sun. Okay, so this is an estimation, a rough estimation. But if this object was right behind the sun, and it has to be behind the sun because brown dwarfs do not emit visible light. So for us to see this object, it has to be reflecting light. So it has to be behind the sun. It cannot be in front of it. So if it's right behind the sun and it looks like 1/3 of its size, then, you know, we can make a good comparison. And we can just say, okay, this object is about 1/3 of the sun. Jupiter is 1/10 of the sun, so we can immediately estimate its size in terms of Jupiter's size. So it's 3.3 times larger than Jupiter. And that is larger than most brown dwarfs are. And yet this object has to be a brown dwarf because it's got the characteristic stripes, and it has to be larger than Jupiter. So what else can it be? It has to be a brown dwarf. So if you scroll down a little bit more.
Okay.
Then, okay, I show the photographs again, and we can see that this bottom one is in true color because you didn't use the blue filter. And you can see that the object is blue and it's got light yellow stripes, and it's beautiful. So this was photographed, I think you photographed this 2 days later.
This one here, when the object was on the bottom, that was May 10th.
Oh, okay.
And then whenever the object was, I think about at the 10 o'clock position, that was a few days later.
Oh, okay. Maybe I got that wrong then, because I got this one off your YouTube video on these objects. But you can see it still looks blue. It looks blue. So in this image, and in the top one, of course, it looks even bluer because you can see there's a blue filter there. Okay, so let's scroll down a little bit more.
Oh my Lord!
So
math.
then what?
Oh my math! Oh
my. It is a little bit of math. Okay, so then what I do is I calculate this object's maximum density. So I gave it the maximum mass that it could possibly have, which is 90 times the mass of Jupiter. And I gave it its true radius according to our estimation from that photograph, which is 3.3 times the radius of Jupiter. And I did the calculation, and I ended up with a density that is 2.5 times the density of Jupiter. And since the density of Jupiter is 1.326 grams per centimeter cubed, then this object has to have a density of 3.34 grams per centimeter cubed. And this is a lot lower than the expected value of 70 grams per centimeter cubed. In fact, it's 21 times less. And you see that this object could actually have exactly the same density as Jupiter, because if I had given it a mass of 36 times the mass of Jupiter, which is still a brown dwarf, well within the range for a brown dwarf, it would have exactly the same density as Jupiter. So basically what I obtained is a brown dwarf that has a density that's much lower than the accepted theories say, the models say, and is larger than what the models say it should be. Okay, so from there on, there are two options. Either the brown dwarf density given in the models is wrong, or brown dwarfs actually evolve in size from, you know, when they start out, they're usually hot. Maybe then they would have a density of 70 grams per centimeter cubed. And then as they age, their density might increase, and at the same time, their volume increases, so that they would end up, when they are very cool, like Jupiter is a very cool planet, gas giant planet, and when they end up at their very cool stage, when they're old, then they would have a lower density. So these are the two options that I'm considering here. And I consider the second option, and that is, let's suppose that, you know, brown dwarfs decrease their density as they age or as they cool down. Comes from. So that's me considering that second option. And that is that they actually change their density. But that leads to a very strange result. And first of all, you see, if this was the case, you would expect so many observations have been made of brown dwarfs in our galaxy. I know they are quite far away, and it's quite difficult to see and get good results from these observations. But yet, no one is saying that there are any objects that have a different density to other objects, because that's what you would expect. You would expect to find the hotter brown dwarfs to have a higher density than the cooler brown dwarfs. So everybody's talking about brown dwarfs of different temperatures, but no one is talking about a change in density. They're all assuming or actually getting the result that they all have the same density, which is 70 grams per centimeter cubed. So it makes this a bit unlikely that this is actually what's happening. So in that case, I would tend towards the fact that this result, this density that the models are using of 70 grams per centimeter cubed cannot be possible. Because don't forget, we are looking at a brown dwarf now that is in the solar system. All the observations so far have been of brown dwarfs that have been sometimes thousands of light years away. So it's very difficult to actually see these objects properly. But now here we have an object in the solar system that can be seen with the naked eye. It's difficult to go wrong with a calculation of its density. So we have to believe that this result that I obtained has to be the true value. Or, you know, it has to be what the model should be using, not 70 grams per centimeter cubed. All right, but then the other thing is that if this is actually happening, okay, because it's possible that they just haven't measured the density properly because they're looking at objects that are so far away. And if it so happens that this object in the solar system is an old and cool brown dwarf, and it has increased its volume and decreased its density, then we get, if you scroll down a little bit more, Scott, we get to the most surprising result of all. Because then, okay, and my other article I spoke about, I compared the brown dwarf stars in the solar system with the white dwarf stars. And it's obvious that there are certain similarities between them. And I got to the conclusion that brown dwarf stars are cooled down white dwarf stars. In other words, white dwarf stars evolve into brown dwarf stars. And I'm tending to the conclusion that brown dwarfs are the result of brown dwarf stars evolving further. In other words, brown dwarf stars would evolve into brown dwarfs. Because in that article, and we're probably going to do it as some other time, I saw that brown dwarfs have a lot of the same properties as white dwarf stars. They pull plasma out of main sequence stars. They have gaseous envelopes. They have high magnetic fields and things like that. We can talk about when we do that. And so, but yet the white dwarf stars have extremely high density, and the brown dwarf stars have a much lower density. So again, we see this evolution where the density decreases. But if an object, as it ages, decreases its density, it means that its ability to gather in the material it's made out of and concentrate it towards its center is decreasing. In other words, its gravitational field is decreasing. And therefore, and since I believe that these objects are electrical objects, and when they are born with a certain electrical potential energy, what I would expect to happen is for these objects to, for that electrical potential energy to decrease in time. That's why stars get old. That's why eventually they stop being able to do certain things, because the electrical potential energy decreases. But then that means that as the gravitational field decreases and the electrical potential energy decreases, what does that look like? It looks like the gravitational field is dependent on the electric potential energy. But don't forget that the measure for a gravitational field is mass. So in other words, this leads to the result that mass is not an intrinsic property of matter, but rather it is dependent on electrical potential energy. Now, we wouldn't see that on Earth because the Earth's electric potential energy has not changed in all the time we've been here. But we can look out into the universe, and if we observe things like that, if we observe, and this is what it looks like, that white dwarfs decrease their density and turn into brown dwarfs. And when we start looking at that result, we say, but that means the gravitational field of these objects is decreasing. So, and that leads to this very surprising result, that it looks like mass is not intrinsic, but dependent on electric potential energy of the object.
You know, I had a question for you. I had a real quick question for you, and this may be so far off, and you may not even know the answer to this. But as I'm gonna pan back up to the actual photograph.
Yes.
And I just did a story last week, and it was based from Science News, and they were talking about a large brown dwarf, a cool brown dwarf. Oh, I forget how many light years away. It was so far away, light years and light years away. And they were able to tell that this brown dwarf had ice and water at its poles from all of those light years away. But like I said in my video, we can't find a cure for cancer, but they can see light years away and see this blue colored brown dwarf. But that was the artist's conception of, I guess, what NASA told him it looked like. I don't know how these artists come up with these views, but when a subscriber sent me that that article from last year, it took my breath away because it looked exactly like the photograph, pretty similar.
Yes.
But in this photograph, what do you think would give this object this blue color?
Okay, so the blue may be, it's possible that it is water. Okay, now the way they figure out that the object has water in it is through the spectral lines. So the spectral lines will be at a certain, you know, in that article that I've just talked about, the white dwarfs and the brown dwarfs, I actually show the absorption spectrum for the sun, where you can see the black lines along in different places along the spectrum, which is basically the rainbow, because it's the dispersion of the light from the star. So there, you will see black lines at a certain distance and in certain positions, and that tells them that there's water in the atmosphere of the object. It doesn't tell you what it's made out of deep down, but what's on its surface, what's in its atmosphere. And they can also tell the temperature of the object by the width of the lines in the emission spectrum. So they can tell that sort of thing, but as to how it actually looks and what the stripes on it would look like, you would have to look at it in a photograph like this one. In other words, it's not possible to actually see this kind of detail if this object is so far away, because you would have to use a telescope, an optical telescope, to actually see the object. And an object that far away, you cannot actually get this kind of accurate detail, only if it's very close, like this one, which is in the inner solar system.
Yeah, that article that was written in that Science News, I'm still very apprehensive about even believing it. I just find it so hard to believe that we have the technology to see all of those light years away, and then to distinguish that this object would have ice on it. Yeah. And I just can't buy it. I don't know. Maybe maybe you could help me out with it.
No, I don't forget that if they knew exactly what it looked like, they would show us pictures of it, and they never do. They show us artists' impressions.
Exactly.
So the fact that they say it's got ice, they would actually have to isolate the spectrum from the poles and figure out that that spectrum is at a cooler temperature than a spectrum from, say, the object's equator. Again, that is extremely difficult. I don't know how far that object is, but it's very difficult to isolate the spectrum from going through different points on the object.
I have to say, it's a beautiful object. I mean, I look at it, you know, every day or every other day, and I keep looking at the photographs, and I mean, it is a beautiful object. I mean, I would much rather see that in our sky every night than the moon. You know.
Yeah, I agree. It is beautiful.
Like, and you know, for instance, when looking at these stripes, because I've had a lot of people asking me, well, what are the stripes? What are the stripes? And if you know anything about Jupiter, they're kind of weather patterns. Am I correct?
Yeah.
They're just completely.
They are cloud formations, just like the Earth has clouds, because there's more water vapor concentrated in the clouds that we have on Earth. These cloud formations on brown dwarfs are concentrated materials along a certain region of the planet that turns into a stripe. Yeah, so that's what it is. And it's also because the object is rotating that it gets these kinds of bands in it, where you get slightly different concentrations of the materials it's made out of.
Now, isn't Jupiter's rotation very, very fast, isn't it?
I think
its orbit is slow, but its rotation is very fast.
Yes, most of these objects have fast rotations, because I think what happens is they start out as main sequence stars, and then they turn into white dwarfs. And when that happens, the angular momentum increases. So, sorry, because angular momentum is conserved, their rotational speed increases because they get so much smaller. So when then they turn into brown dwarf stars, and then perhaps into brown dwarfs, they never go back to the same size that the main sequence star had. And the main sequence star has a slow rotation. For example, our sun has a 24-day rotational cycle, whilst the brown dwarf stars that have observed, most of them have something like a 27-hour rotational period. So they are rotating so much faster. So this is the other thing, and that's a good point. Maybe I should look into that some more. And that is the rotational period. I think I should write something about that. I haven't yet, but I should. And yeah, that's a good point. So that's a characteristic of these objects. And that's another point that shows us where they came from. Basically, so far, the evidence suggests to me that all these objects were once main sequence stars. And they have evolved through a certain process. And some of them are brown dwarf stars. And once their electric potential energy has decreased to an amount where they can no longer do things that brown dwarf stars do, like draw plasma from the sun, then they may turn into these striped objects, the brown dwarf.
So just so we're clear for everybody, as we were talking about on our live stream this morning,
Yes.
this object, even though it may be relatively close to our planet,
Mm-hmm.
we're not in any danger of this object, this blue brown dwarf, because I don't want anybody to think, wow, this thing is so close to us, it's the end of the earth as of right now. But would you consider this to be more of a planetary object? These larger brown dwarfs, almost
Yes.
pretty close to a planet in between?
Yes, I think they are just very large gas giant planets when they get into this brown dwarf stage. They are not drawing a plasma. They are not emitting large amounts of radiation. They're not having ejections, although the hotter brown dwarfs can have jet-like ejections. But the cooler ones that have become this large, I don't think they do. I think they're pretty harmless. They're not. The problem, well, the only thing they could possibly still have is a large magnetic field. And as you know, the magnetic field of such an object can affect the Earth's magnetic field. So just like Jupiter has a large magnetic field, that's another characteristic of these objects, because white dwarf stars have very large magnetic fields. And it's also due to their rotational period, which is quite fast.
I guess
these objects...
I guess the scariest thing would be is if, you know, everybody around the world started actually seeing this object in the sky with the naked eye.
Mm-hmm.
That would probably be
Yes.
the scariest thing that would be dealt to the Earth.
Yes.
If you wake up one morning and you happen to go out to get the Sunday paper and you look up and you don't see you see the sun, but then maybe off in the distance somewhere you see this large blue, beautiful striped object.
Mm-hmm.
Yeah.
That would be very interesting. And I would actually like to ask people who do see it to film it and upload it to YouTube, because the world needs to know that this object is up there. And the more people see it and make videos of it, the better.
Can these brown dwarfs or the brown dwarf stars? There was a question in here. Just let me grab it real quick. I had actually had this question before. Can these brown dwarf stars, can they turn into a gas giant at some point in their life?
Well, this is basically what I am saying is happening. You know, I'm still writing up the third article on this.
Okay.
Where I basically say that because brown dwarfs have certain properties that we see in the brown dwarf stars, and because in the brown dwarf stars we see properties that white dwarfs have, I see a line, an evolutionary line between the white dwarf, the brown dwarf, and the brown dwarf, which this object is an example of. And because this particular object has a density that is so close to Jupiter's, then you start to realize that these objects are actually a lot more like gas giant planets than has been suspected up to now. So I would go as far as say they are in their cooled down and at this density, basically gas giant planets, except for the fact that they have been defined by reason of their large mass as brown dwarfs. So that's the only differentiation that we have, is because their mass is above 13 times the mass of Jupiter. We cannot call them gas giants, even though technically they are. We have to call them brown dwarfs. But that's only a matter of the definition. Basically, they are gas giant planets at this stage.
So right now, with this discovery here, everything that we've been working on, you could sit down and rewrite the science books for teaching around the world, based on what we're looking at.
Yes, Scott, I think that's one of the reasons why they want me to keep quiet, is because
yeah, they don't want to pay for all the printing cost to rewrite the books.
Yes, you see, in the end, it costs them everything, because when you realize that the gravitational force is dependent on the electric potential energy, and in my last paper, I go on to say, we're seeing fusion reactions in brown dwarf stars, and they are cool. We know they are cool because they're not emitting visible light. How is it possible to have fusion reactions on a cool object?
Exactly.
The only possible reason is cold fusion. And they have been fighting the idea of cold fusion since the 1980s. This has been a big battle. And I'm going to write yet another paper, because when I saw that this is happening, and I'm putting it in the paper I'm writing right now, and then I'm going to write one that specifically explains why the sun's corona is hotter than the surface. And I believe I have the answer now. I believe that what is happening on the sun is not hot fusion, is cold fusion. And it happens at a much cooler temperature than the millions of degrees they say it should happen. And it happens because there's an electric field on the sun. To have cold fusion, you have to have an electric field.
Yes.
And so there is an electric field, and therefore cold fusion is possible. And then the cold fusion leads to heat emanating from the surface, which then explains why the corona is so hot.
Well, I could tell you this much.
So you see,
all of these
yes.
theories and all of this information, this would definitely cause astronomer scientists back in the day to literally turn over in their grave. Am I correct? what we're talking about?
The thing is,
the cold fusion, they would be turning over in their grave. I think I hear them flip-flopping right now.
Yeah. I think a lot of ears that are listening to me right now are burning because they are so angry that I even bring the subject up.
You know, I'm sorry, there was one other question that I had, and it keeps slipping my mind, and I keep looking at this photograph. Is there a possibility when these brown dwarfs, like this blue one, is it a possibility that they, whenever they were far, far out in space, very far from our sun, is it a possibility that they were a different color, and as they came closer to the sun, experienced the sun's heat, that they transform because of our sun's energy? Or would they basically stay the same color?
Well, if we had a brown dwarf star that evolved into a brown dwarf, we would see a change in the color, I think. But I think this object probably came in with this color pattern already. I don't think there has been enough time for it to change a lot in the time that it's been. And the other thing that alerted me to the fact that these objects are actually main sequence stars at the end of their evolution is the fact that this object came in with the other brown dwarf stars. And remember, I deduced that these objects are attracted to the sun, and that stars are attracted to the sun, just like protons and neutrons attract each other in the nucleus. So from that, it suggested to me that this object is also a star. Of course, it's possible it was actually orbiting one of the stars. But to me, its size and the fact that it seems to orbit the sun, move right around the sun, whilst the other brown dwarf stars seem to have different orbits. They seem to come in right up to the sun and then move away again. This object is orbiting the sun. It's behaving like a star that is attracted to the sun. So to me, I started thinking, wait a minute, but then brown dwarfs are stars, but they're not newly formed stars that have just failed the grade to become stars that fuse hydrogen into helium. To me, they are old stars because brown dwarf stars are old stars. And these brown dwarfs, to me, are even older than brown dwarf stars.
So they're the oldest of the old. They're the oldest of the old.
Yeah, I think so. Yeah.
Yeah, the one seminar conference that I watched from Harvard and Cornell, they had mentioned that also, that these were some of the oldest substellar objects, you know, in the universe, the galaxies, and still quite amazing. You know, I look at this, photograph, and I could only wish that I could be in, you know, the largest observatory on the face of this planet and see this object crystal clear, you know, crystal clear. Because it is amazing. Yes. It is amazing. Yes. And I know that there are, you know, there are so many people that are in disbelief, but I don't know what to tell you. You know, it is what it is.
It is what it is. It is evidence, like I said before, beyond anything I ever imagined we would get. And I still think it was a miracle that God allowed you to take this photograph. I mean, you didn't even know you were taking it at the time. And so I'm still amazed. I love looking at these photographs. It's such a beautiful object. And it's such corroboration of all the work that I have put into this over all these months to actually see there's a brown dwarf right there close to the sun. It's very satisfying.
Yeah, it is. It is. It is an amazing find. I don't think that I don't think any credit will ever be given. And I'll be quite honest, I'm not looking for any type of astronomy notoriety. I mean, I would love to see them investigate it and tell the truth. But I know that's not going to happen. I mean, it just seems to me that modern day astronomers, I don't know, it just seems like they don't have the balls to tell the truth about something that's close in our solar system. But yes, they will tell the truth about something that's 50 light years away.
Yes.
You know, they'll talk about that. They'll talk about that imaginary planet 9 that it you know, They mathematically figured it out on a damn chalkboard, but they never visualized it. We'll talk about that. They'll give them, you know, a whole hour show on 60 Minutes.
Yes.
Yeah. Anywho,
That's right, Scott.
I think we had a, were we close to the conclusion on your?
Yes, but we basically got to the conclusion where I summarized the result. I can read through it if you like.
Yeah, that'd be great. That'd be great.
Okay, so I said, in conclusion, the blue brown dwarf in the inner solar system has a maximum density of 3.34 grams per centimeter cubed, which is not far above Jupiter's density of 1.326 grams per centimeter cubed, thus suggesting that either the accepted density of 70 grams per centimeter cube for brown dwarfs is wrong, or brown dwarfs decrease in density as they age. So that was my conclusion.
So this blue object, so it is because I am horrible at math, especially your type of math. How much larger do you think this object is than Jupiter?
Well, it's over 3 times larger.
Oh my God.
Yeah, that's why. It must have a huge mass to be 3 times larger, because don't forget, density is mass divided by basically a few numbers and then radius cubed. So the radius, even though it decreases by just a little bit because we cube it in the density, it's a large factor. Okay, so the fact that it's 3.3 times larger than Jupiter means that its density has had to decrease enormously from what a typical brown dwarf would be, you would have. Yes.
Wow. Because, you know, I just think about planets in our solar system, and, you know, they say, well, the Earth is just a relatively small to medium-sized planet. And then you think about the size of Jupiter and Saturn, and then now to think about a planet being 3 times the size of Jupiter is just, I don't even know what to say. That is a massive, massive object. And that would be pretty wild, you know, being in our solar system. I mean, that would be, to me, that would be the biggest news ever.
That's right.
You know, I mean, with everything that's happening around our world today, with the way the climate's changing, the climate chaos, all of this crazy confusion and all of these theories, and then all of the disinformation, and, well, basically just, you know, the New World Order, Illuminati, whoever you want to call them, whatever you want to call them, trying to shut this down. But this is the biggest find of a century. This is the biggest find of all mankind.
Yes.
And they want to silence it. Yeah.
Absolutely, Scott. This is the biggest thing we have ever discovered about our solar system. And it changes everything. Like I said, I mean, I don't have access to all the data. I'm just estimating the size and calculating the density. And look what I could figure out just from that little calculation, Scott. And, you know, all the evidence I've looked at and all the observations I've made due to the HI images. And basically, that's what I go into in this article. And now, basically, I'm putting it together with the observations that have been made over the years about white dwarf stars, because I've always thought that these brown dwarf stars, or these objects that I've called brown dwarf stars, have some of the same properties as white dwarf stars. So now I actually went and started comparing it. And when I start thinking about that, basically it leads to the rewriting or of a whole lot of theories, because then you start deducing certain things that have not been, anyone has been able to deduce, because they were not examining these objects in the solar system. This is why they don't want us to see it, because this is what happens. And if I had the right instruments, that if I could look at these objects in more detail and find out what the actual temperatures, surface temperatures were and things like that, I could get a lot more data and deduce a lot more things. But what it does is it changes all the theories that they use to hold back the progression of physics. For example, the gravitational theory and the fact that the electric field never actually plays a part in star formation. All that goes out the window because we now have observations of objects in the solar system that give us all kinds of data that forces us to throw away these outdated theories that cannot possibly be true in the light of what's happening in the solar system.
I'd have to agree. You know what just hit me? Just a thought just pulverized me right in my brain. And I'm sitting here thinking that we've made this absolutely astounding discovery. But if I was able to see it, then that means observatories around the world, especially ones associated with the government, they had to see it first.
Oh, yes.
So I was going to say, then they should let us name it, but if it's going to be here for a while or whenever, but it just hit me that they've seen this object.
They've been seeing it for years, Scott.
They know it's there.
Yeah.
Yeah,
this subject.
That just hit me like right between the eyes as I was it just hit me. That I'm thinking,
you see,
wow.
But they still are going to have to let us name it. Because you know what? They're never admitted to having observed it. They never did. And we did.
Yeah, I could see that not happening. I could see that not happening at all. I mean, I don't see them putting us on the stage.
Maybe we should name it Scott's Brown Dwarf.
Yeah,
Scott's Blue Brown Dwarf.
Yeah, they'd sooner put a bullet in my head than to give me, that notoriety. I can tell you that right now. Because if they're not publicizing it to the world, and this would be an astronomer's dream right here. I mean,
I know.
This would be orgasmic for an astronomer.
Yes.
And for them to keep their mouth shut, then they had to be scared for their life.
Yeah, that's why they killed a whole lot of astronomers. They were all on a plane, I believe, and they were going to have a conference, and I think they were going to discuss these topics.
Yeah, they
all got killed.
Yeah, they downed the plane.
And so, because astronomers, it seems to me that they talk amongst each other, but they refuse to go into this because they know their lives are on the line if they do.
It's just absolutely amazing. So this next report that
Yes.
you researched, this has to do with the white dwarfs and their process into a brown dwarf. And they say this takes trillions of years, but I mean, who even thought up those figures? Sometimes I wonder where scientists come up with these figures on the age of the universe, the age of a substellar object or a planet, or even a rock found here on Earth. And then to say that these white dwarfs, it takes trillions of years for them to cool down enough to become a brown dwarf. Where did you think they come up with this stuff?
Well, it comes from basically theories that have been falsified. For example, the age of the universe comes from the Big Bang Theory, which basically says that redshift is due to recessional velocity. But there is plenty of evidence that that is not so. There are objects, basically quasars, that look like they are ejected from active galactic nuclei. And you can actually sometimes see these objects inside the galaxy itself as it is being ejected. And you can see these objects, because quasars are very high redshift objects, connected by dust to galaxies that are low redshift. So there are so many of these photographs. So the theory has been, as far as I'm concerned, completely falsified. But yet they are still using it. And the peer review system makes sure that you keep on using it. Because if you use the other theories, basically, that the universe was not created in a Big Bang, and there's the steady state universe and so on. These theories are not well accepted, and basically the peer review system keeps it out of mainstream physics.
And then they would have to rewrite everything.
Yes, they don't want to rewrite everything. And basically, it's also a question of economics, because when you realize that cold fusion is possible, what do you think is going to happen?
Oh, boy.
A whole lot of research and development. There is some going on, by the way, but a whole lot more would have gone into it. And by now, we would have cold fusion. We would have no need for these nuclear power stations that are so dangerous, because cold fusion is clean and it happens at cold temperatures. You see, we wouldn't need to burn fossil fuels either. Of economics, because the powers that be have based the economy on black gold, which
Absolutely.
is basically gas.
Absolutely.
And they are making money and controlling the world through it. This is part of the reason why they don't want this information out, because it changes the economics in this world.
Very true. So what do you have for us here with this, with the paper that you wrote on this, on the white dwarfs?
Okay, so I start out. So this is all about comparing white dwarfs and the brown dwarf stars we have in the solar system. And I start out by saying that white dwarf stars are extremely important, because 95% of all stars in the universe are expected to become white dwarf stars at some time. So they are a very important part of stellar evolution. And they are very important in our understanding of what's going on in the solar system. And then I explained that one of the characteristics of white dwarf stars is that they are hydrogen deficient. That is, they have atmospheres that have very little hydrogen in them. Although you do get some that have more hydrogen than others, but most of them have very little hydrogen, because these white dwarf stars are what result when an object runs out of hydrogen, because it's fused basically all of it into helium. Now, to find out what's in the atmosphere of these objects, we use what's called an optical spectrometer. So here in the figure is an illustration of one. This one is for astronomical use, because it's connected to a telescope. And basically, it has a diffraction grating. And the diffraction grating disperses the light. So it's split up into the different frequencies. And each frequency is associated with a color. So you basically get a rainbow pattern spread out. And then it's connected to a detector. And the detector measures where the spectral lines are. So if you scroll down a little bit more, you'll see there's a spectrum. The next figure is the spectrum. You see, so this is an absorption spectrum for the sun. And the position of these absorption lines tell you what element it's associated with. The instruments they use nowadays don't actually use they used to use just, looking at it with your own eye to see the patterns and so on. Nowadays, we have instruments that actually measure the exact wavelengths where the spectral lines occur. But wherever these spectral lines are and their distance from each other tells you what element is there. So that's what it looks like. As you can see, it's got the background is, looks like a rainbow. And then, so that's how they discover what's in the atmosphere of a white dwarf. But you cannot forget that absorption spectra only tells you what's in the atmosphere of a star. It doesn't tell you what's actually inside it. So when we talk about what's inside it, it's based on a certain model. But here I do use what the models say because it's plausible, okay, from what we expect to happen. That is, a main sequence star runs out of helium, and if it's of a mass less than half the mass of the sun, it's not supposed to go any further. It's not supposed to be able to go any further. So it becomes a helium core white dwarf star. All right, so maybe we can scroll down a little bit more. All right, so they're stars that are between half the mass of the sun and up to 8 times the mass of the sun are expected to be able to fuse helium when they run out of hydrogen. And they turn this helium into carbon and oxygen. And then the white dwarf star that results will be a carbon-oxygen core white dwarf star. Because these stars, if they have a mass of less than 8 times the mass of the sun, are not expected to be able to fuse elements into heavier nuclei. So, and these carbon-oxygen white dwarfs are supposedly the most common white dwarf in the universe. Stars that are more massive than that are supposed to be able to fuse carbon into, say, neon and so on, but there are less of them. And we're supposed to eventually get stars with a mass of 10 times, a mass that is 10 times greater than that of the sun, to be able to fuse neon into iron, and then we should end up with an iron core white dwarf star. Because iron is where the fusion reactions stop, because you cannot fuse iron into heavier nuclei and have energy given off. You have to actually put in energy into the fusion reaction to get it to happen. So that's why fusion, in order to provide energy inside a star, stops at iron. Now, most models or most astrophysicists will say that we should not actually get iron core white dwarf stars because before the object can turn into a white dwarf star, the gravitational forces are expected to turn it into neutron stars or black holes. I'm not actually convinced that that's true because I know that the gravitational force does not play that much of a role as most astrophysicists think. So I do still think that iron core white dwarf stars are possible. And I actually came across a paper that agreed with me. I'll eventually put it out somewhere. I did find a paper, but it was an older paper, where they saw these white dwarfs and they looked at the densities, and they thought the only way we could have a white dwarf of this size and this density is if it has an iron core, yeah. So some astrophysicists will agree with me, and a lot of them will probably disagree with that. But it doesn't actually matter, because what I actually want to do is compare the properties of white dwarf stars with the properties of the brown dwarf stars that are in our solar system. Here we see an image of a white dwarf star. They have very bright very hot surfaces. Okay. Most people will say, and this is the other theory that has stopped things from evolving in physics, and that is that the accepted theory for the powering of stars is fusion reactions from the core of the star. So it is believed that the sun is powered by thermonuclear reactions from its interior. And I don't believe that is possible. And because of other things, which I will explain later on in this paper. But if that's the case, white dwarf stars will be cooler on the inside. And therefore, they will cool down much faster than we would expect. Whilst astrophysicists believe that a white dwarf star, because it's this temperature on the surface, it has to be the same temperature or even hotter inside, right down to its center. And that's the problem. Okay, so we can scroll down a little bit more.
Has there been any discoveries of white dwarfs recently?
Yes.
Like as far as distances, because I haven't read much about them because I've been so enthralled in other subjects.
Yeah.
But I haven't read too much about them.
They pretty much know where all the white dwarfs are, because they've been studying them since the 1960s. But what they are still doing is researching certain aspects about the white dwarfs. And they're trying to come up with models on how you can, say, combine two white dwarfs to get a certain star. How to get extreme helium stars and so on. And some other stars. So they are still studying them, and they're still measuring. For example, there are some papers that I came across about people that are doing research into whether the mass versus the radius ratio of these stars, whether it holds, because there is a certain expression for that has come out of the research over many years, but it hasn't actually been experimentally tested or observationally tested. So some people, I've come across some research into that. So yeah, so they are still doing research, but I think they know where these white dwarf stars are, because they are very bright and therefore easy to see, even though they are so small. They are white, so they spectral class A objects. So they are, from the fact that they emit that white light, that they know that their temperature, the surface temperature, is very high.
Yeah, very, very hot, very hot.
Yeah. Yes.
So
so what I didn't.
They've known about these white dwarfs for quite some time then.
Yeah. Oh yes, they started discovering them in the 1960s.
Oh,
yeah, Scott, I just forgot something.
Yes.
Yeah, I forgot something to mention about that white dwarf image. So can we go back to it first?
Yep, here we go.
Okay, so white dwarfs are known to have gaseous envelopes and to be surrounded by a cloud of ionized gas beyond that. So basically, that's what we see here. There's sort of it's often broad disc-shaped envelope, and it's made out of ionized gas, and it's part of what's left of the star when it was in the red giant phase. And then beyond that, that's another cloud that is more diffuse of ionized gas surrounding the star. And that's basically what we see here. Even though this is not a true picture, I believe this is an artist's impression as well.
Boy, I'll tell you, those artists make a lot of money off of NASA drawing their pictures, don't they?
Oh, yes, they do.
Jeez.
Yes.
Goodness, I should have went to NASA art school, for God's sakes.
Maybe you should have.
Oh, looky what we got here.
Yes, this is the first brown dwarf star
And this is
Although
what got me into trouble. This is what got me into trouble, ladies and gentlemen, back in late August of 2016. This is what put me on the map, put me on the radar. Was divulging this information.
And you know why they did that to you now, Scott? Because when I saw this object, I thought, oh my goodness, this is it. I've never seen one like this before. I knew exactly what it was.
Now, ladies and gentlemen, this is part of some imaging from, I believe this was Core 2 from the stereo imaging from 2007, February 20th, 2007. And I don't have the actual video footage up or ready, but it shows that little spherical object that you see the blue arrow pointing at, and it literally orbits the sun very rapidly. And I was told by the YouTube channel Astronomy Live and Dazza the cameraman that it was our moon. It was our little moon, you know, the one above the Earth. And it was orbiting the sun all by itself, 93 million miles away. It came back around the sun and joined the Earth again.
Yes, it's ridiculous, Scott. But you can see that that cannot be the moon. When did the moon ever grow a gaseous envelope that glows? In fact, it has plasma discharges in it. That's the only way it glows. And if you observe the object, it glows when it's far from the sun. And as it moves closer to the sun, it stops glowing. It goes completely dark.
Yeah.
And you can actually see what it's doing. It's going from energy emission mode to energy absorption mode. And then it actually traverses the sun. You can actually see it's inside the corona. Okay, so I've written a couple of articles on this. You can actually see the corona above the object. That's the only way it can glow from the top of it, so that we can see it with coronal ultraviolet light. So, I mean, if it was the moon, and even if you say the moon was orbiting the Earth and it got in the way of the satellite, how would you see the corona in front of the moon? It's impossible. There are so many things that are impossible for this object to be the moon. But you can actually see it's got an envelope. It's a broad disc-shaped envelope, just like the white dwarf stars are reported to have. And it glows, which means it's ionized gas, and there are plasma discharges in it. The core of the star itself is dark. And then I know in the PDF files it doesn't come out as well as in the Word documents. But in the Word document, you actually can see, and if we watch the video, you can see the cloud of ionized gas beyond this gaseous envelope. What is this? This is basically what a white dwarf star is supposed to be like, except it's large and the core is dark. That's why I called it the brown dwarf star. It's got the same characteristics, except it's dark. So it's got a lot of the same characteristics. It's got a few of differences. So to me, it's an evolved white dwarf star that has moved from the white dwarf stage to the brown dwarf stage, brown dwarf star stage.
You know, I would love to pull this footage up so everybody can see it, and maybe we'll do that at the end of your presentation, so everyone can see the moon orbiting the sun, as per Dazza the cameraman and Astronomy Live, trying to pull the wool over my eyes, even with their fake little simulation program that they developed a few days later to try to trick me again, which I never bought in the very beginning because it was all nonsense. But we will do that at the very end. Yeah, we'll pull up the footage from February 20th, 2007. And ladies and gentlemen, you be the judge. I have publicized this video many, many times over the course of the last 10 months. And each time I have fallen under serious machine gun fire from the troll factions, because they all want everyone to believe that that object was our little baby moon zipping around the sun all by itself. But anyways, Doc, you go ahead and yeah. We're going to bring that up later.
Yes. Okay, now this object, because it traversed the sun, I was able to estimate its size. And it's 1.7 times the size of Jupiter, or 17 times larger than the Earth. So it's much larger than the typical white dwarf star, which is basically the same size as the Earth. So basically 17 times larger than a white dwarf star. So you can see something happens to these objects to get from the size they have as white dwarfs to the size they have as brown dwarf stars. And notice that 1.7 times is larger even than the typical size of a brown dwarf, which is supposed to have a maximum size of 1.2 times the size of, which I explained in the first article we did. All right, now the other thing that is characteristic of white dwarf stars is that they are able to pull plasma from main sequence stars. And we see that the brown dwarf stars in the solar system can do exactly the same thing. And we can see in these SDO images, so in different wavelengths, the 17.1, the 30.4, and the 19.3. Now, I did this in the 3 wavelengths for a reason, because it's clearer that it's a round object in the third image, the 19.3. And because you can see more of it because the corona is larger there. And in the middle image, you can see how broad that line of plasma is connecting the sun with the object. So I wanted to specifically show that it is plasma. In the other 2 images, that line looks dark, but in that middle image, it looks exactly the same color as the plasma in the sun. So we know that it's drawing plasma from the sun.
Yeah, now this, ladies and gentlemen, these images right here that the doctor is talking about, there is if you follow my cursor over here to the left on the yellow image, there is a very dark sphere right here where my cursor is. And there's a small line which it is drawing plasma directly from the sun, almost like an umbilical attachment. And I remember when these images made their way through the UFO channels, and basically they were saying this was a UFO, recharging itself from the sun. And I mean, I don't know, anything's possible nowadays, but you could believe whatever you want to believe. But yes, it's not a UFO drawing energy from the sun. And this has been criticized and scrutinized over and over. And then just recently, I don't know, another YouTube channel came out, brought this up and said this is what a stealth CME, coronal mass ejection, looks like. And I don't think that's possible. I don't think that's possible at all. But you can see the object right here, right inside of the sun's corona, and you can see the attachment, the plasma attachment. That's what that would be, right, Doctor? A plasma attachment. Yeah,
it is. It's actually a flux transfer between the 2 stars. But this is what white dwarfs do. They also do exactly the same thing. They draw plasma from main sequence stars if they are close enough to them. And I believe that it's actually a connection through the magnetic field lines, where these objects have high magnetic fields. And when they come right up to the sun, the sun's magnetic field lines are pulled towards it. And through that, then the plasma spirals around the magnetic field lines, and it goes right through to the star. But the accepted theories on white dwarfs talk about, they basically seem to think that it's gravitational. So, well, I use then the gravitational attraction that you would have, that a white dwarf would have, for the plasma to actually calculate the density, but of these objects. But we look at that. I'm not even sure anymore if I put it in this article or the next one I've written. So I think for this one, I'm just looking at the characteristics that tells you that brown dwarf stars or white dwarf stars, they're just cooler and not as strong as white dwarf stars. Okay, so if we scroll down some more. Okay, then that object that we saw there, I estimated its size by comparing it with the sun. And this is how I do it. So I take the 19.3 nanometer wavelength image, and I draw a little circle there that's supposed to be exactly, it's about the same size as that little brown dwarf star down there. And then I align them right along the diameter of the sun to see how many I need to make up the sun's diameter. And I needed 21.
Ooh, that's a big object. That's, I mean, this object is, I mean, even though it takes 21 of them to go across the equator of the sun, that's still a large object.
It is large. That's the thing. It's about half the size of Jupiter, so 5 times larger than the Earth.
Oh my.
Yeah, yeah, it's quite a reasonably sized object. Don't forget, it's smaller than the first brown dwarf star we saw, which was 1.7 times. I mean, it's like almost a quarter of the size of that one. But I believe that the smaller they are, the stronger they are. Because white dwarf stars, remember, are tiny, the size of the Earth. And the ability to draw plasma from another star, possibly due to their magnetic fields, is a lot stronger than these objects, because white dwarf stars can do it from further away. These objects have to come right up into the sun's corona to be able to do it. Okay, so
21 times
we can
size. 21 times.
Yes.
That's, yeah, good observation.
Okay. Yes, thank you. I mean, that's what I use to estimate the sizes. Okay, here what we see is an object which is a brown dwarf star. You see it's moving to the right. I think it's a brown dwarf star because, first of all, it's got a plasma loop. And the plasma loop, you know, it has to have plasma to be drawn and spiral along the plasma loop magnetic field lines. So it's got to be a star, and the size of that magnetic plasma loop tells you that it's got a very strong magnetic field, which is a characteristic, I think, of brown dwarf stars and white dwarf stars. You know, they both have very high magnetic fields. And then what you see there is what I used to think was a CME, but now I think it's maybe something different. It's like a huge explosive ejection, so that the object suddenly increases its size and brightness to an amazing level. So that's what we see these brown dwarf stars are able to do. So if we scroll down a bit more.
Yeah, those look exactly like the plasma loops that you see on the surface of the sun.
Exactly. Except they are so much larger than this tiny little object that produces them.
They're massive.
Okay, so there you see it again, and different plasma ejections. There's the huge one that I'm going to later on explain what exactly that is. But you see, it's that plasma that grows into that round, huge ball shape. It doesn't move away from the object like you would expect a CME to move away from the object. It looks like the object suddenly grows, and then later on it decreases in size again. And it takes a few days to do that. And then it's got that jet. You see that jet in the middle image. So that's another type of ejection. It goes actually for quite some distance away from the object. And that's a characteristic that actually brown dwarfs have, because I think actually Chris did a video on this brown dwarf that had a huge jet ejection that was 0.7 light years in length. So here we see that these objects also have brown dwarf characteristics. That's also one of the reasons why I think the brown dwarf star is in between the white dwarf star and the brown dwarf objects, which are basically, as I explained before, gas giant planets. Okay, so scroll down a little bit more. These images are they were SRAM images which detect ionized particles, but this one is invisible light. So you can see that what happens is not just about particles, it's a visible light emission that happens. Okay, so then we can scroll down.
This is the imaging, though. I did a few videos on this myself, and the claim was this was Venus. Am I correct? They were claiming that this was Venus, and this was
they usually
a reflection.
They usually label these objects Venus, but you can see it cannot be Venus because Venus cannot have plasma loops. I mean, it cannot be. First of all, it's not a reflection because you cannot see reflections in SRAM images, because SRAM images you only see particles. It cannot be a lens flare of any kind because it's in the SRAM images, and the SRAM images are not visible light images. You would perhaps get a lens flare, but it's extremely unlikely in visible light images because the detector has a lens in it. But the SRAM detectors don't have lenses in it, and you see exactly the same thing in them. Yeah. So it's obviously not a lens flare. It's obviously not any kind of reflection. It's actually something that's happening to that object. And that object has plasma, and therefore cannot be a planet. It's got to be a star. It's got to be a star with plasma on it to be able to do something like this.
Yeah, that's a telltale plasma loop. That is identical to what you see on the sun. Yeah. I mean, one day I'll do a video and we'll point these out to you if you've never seen them on the sun before. But they loop themselves up and then they reconnect to the sun in a perfect loop, just like this. They almost look like ribbons flowing on top of the sun.
Right. Mm-hmm. Mm-hmm. Okay, so we can scroll down some more. I explained that, which I've just said. Mm-hmm. Okay, now here I explained that 2 out of 3 stars are born in a binary star system. And we see here, it's another artist's impression. This is a main sequence star and a white dwarf star. And the white dwarf star is pulling plasma from the main sequence star. You can actually see the line of plasma connecting the 2 objects. And what then the white dwarf star is, it gathers the material, the plasma from the main sequence star in a ring. It's called an accretion ring. And then eventually, the of the plasma at the white dwarf surface gets to a critical level, and you get hydrogen to helium fusion reactions. And when that happens, you get what's called a nova outburst, where the white dwarf star seems to grow to a huge size and become extremely bright. And it often it doesn't stay like that, because You don't get a continuous input of plasma always. There are usually instabilities in it. So the star goes through different phases. It goes through this nova outburst phase, and then it becomes quiescent again. So it goes back to its normal brightness. So, but the fact that this happens with white dwarf stars, what I'm saying here, this is what we saw in the image above happening with the brown dwarf star. That's why it suddenly gets so large and big. That's a nova outburst. So these brown dwarf stars in our solar system are having nova outbursts, just like white dwarf stars. And this is astounding. It means there are really white dwarf stars that have evolved to the point where they are cool and not as strong as white dwarf stars. So if it is possible that a supernova can happen if the density gets so high that you start getting helium to carbon fusion reactions. And in that case, the supernova explosion, what it does, it may actually destroy the white dwarf star and eject the main sequence star at high speed away from that point, out into space. But most of the time, what has been observed is just these white dwarf stars have nova outbursts which recur over a period of days to decades. Okay, so
let's hope we don't have one of those. Let's hope we don't have one of those in our lifetime in this this endeavor that we're involved in.
Yeah,
that would be
because white dwarf stars, because they are so much stronger than the brown dwarf stars we have, the type of nova outbursts they have are huge compared with the ones the ones we have in our solar system now. Because basically what we're seeing in these HI images are nova outbursts. But the brown dwarf stars are so much weaker that they are so much smaller, and therefore they don't cause as much destruction. All right, so so that shows you that, you know, that's basically what I found extremely surprising when I started comparing the white dwarf stars with the brown dwarf stars. I mean, it becomes obvious. These brown dwarf stars are so close to white dwarf stars. All right, so then I explain the accepted theory and why I think that the white dwarf stars cool down so much faster. And I say, okay, we can get the Big Bang model out of the way, but I've explained that already. And I say, once we have the Big Bang model out of the way, the universe may actually have an infinite age. And then I look, okay, now I just want to mention something, because people think that just because the universe has an infinite age, that God could not have created it. I don't think that's true. Don't forget, God is outside of time. So when he created the universe, he created time. So he created every space point and every time point from infinity past to infinity future at the same point in time for him. So God can create an infinite universe in expanse and in time without any problem, because he's a being outside of time. So I just want to mention that, because sometimes people think that just because you throw the Big Bang model out, it means that God didn't create the universe, and that's not true at all. All right, so then I explain about sunspots. And what we have here is a sunspot, and the sunspots are we can actually see into the sun's surface. You actually go down thousands of kilometers into the surface of the sun. You can see it's dark inside. Now, if there were thermonuclear reactions coming out from the interior, that spot in there would be brighter then the photosphere, which is the surface of the sun, where the sunspots actually are, and where the light that we see comes from the sun is produced, is basically it's the surface of the sun. So we can see from that that our sun, and if we measure the temperature inside that sunspot, it's cooler than the rest of the photosphere. And the deeper down, the closer we are to the dark portion, so basically going inside into the sunspot, the cooler it gets. So that shows you that the surface of the sun below the photosphere is cooler than the photosphere. And therefore, the interior of the sun has to be cooler than the outside surface of the sun. So if the sun is like this, we would expect white dwarf stars to be cooler on the inside as well, because we basically are translating what we're seeing in the solar system, which is the way we're supposed to do it. I mean, not look thousands of light years away, calculate the surface temperature of the sun, and immediately assume that it's the same as the interior temperature, because what are people doing? They're ignoring the fact that sunspots look the way they do, and the fact that the temperature is lower inside the sunspots, and just go with the model that says that, you know, the sun is hot on the interior than on the exterior. So this is what I'm saying here. Stars are cooler on the inside. White dwarf stars are cooler on the inside, and therefore they take a lot less time to cool down than the models predict. Okay, so we can scroll down some more.
That's an amazing photograph. I think that's the closest photograph that I've ever seen in that much detail of a sunspot.
Good. Yeah, so here I explain what, you know, after explaining all these similarities and about the fact that we cannot actually have thermonuclear reactions coming out from the sun, because then the interior of the sun would be brighter and hotter, and that's not what we see can possibly be happening from looking at the sunspots. And then I have this little image where I try to explain what's actually happening. The white dwarf star emits bright white light. Its surface is hot. And through a certain period of time, it evolves in what's called a brown dwarf star, which emits mainly infrared light unless it has a nova outburst. So that's what I've explained in, I just wanted to put it in a diagram that summarizes the idea. And then it's just the conclusion here. So I say observational evidence gathered on white dwarf stars over many years, and the observational evidence, which I have detailed in this article, suggests that the brown dwarf stars close to our sun are cooled down white dwarf stars with the same, but perhaps weakened characteristics and capabilities of white dwarf stars. It also seems that these stars grow in size as they cool down, or as they evolve from the white dwarf to the brown dwarf stage. Okay, so that's my conclusion. I don't go further into it in my next article where I'm still finishing. I actually go into the fact that because of this happens, they grow in size. It means their gravitational force has to decrease. There has to be a huge mass decrease from the white dwarf to the brown dwarf stage. And what else happens? The magnetic field decreases, and the electric potential energy the star has to decrease. So it means that mass, again, is not intrinsic. It is electric potential energy dependent. Or you could even say electromagnetic field dependent, because these objects, of course, have electric field and magnetic field. I like to use the idea of the electric potential energy because I believe that they are electrical objects, and that's what actually causes the sun and other stars to be able to accelerate particles away from them. It's through the fact that they have this electric field a strong electric field will accelerate particles away from the electric field. That's basically what I've talked about. It is actually possible that the field that I'm talking about is not an electrical field. I have come across the idea of the 0-point energy field, which would then give rise to the rest of the interactions, which are the electric, the magnetic, and the gravitational. But we can see from here, even with the idea of the electrical field, that the gravitational field changes for these objects, and therefore their mass changes, and therefore it means mass is not intrinsic. This is such a huge deductive idea that I have gathered from this, that I'm still resonating from it, because I actually realized this today. I mean, earlier today, that I was thinking, I guess for you may have been still last night. I was still thinking about this, and I realized, oh my goodness, this is what it means, that mass is not intrinsic. It means that mass can vary. It can be created or destroyed by an electric field. And it's just astounding.
Yeah, that was absolutely incredible. You know what I wanted to ask you, the footage that we see the moon. Oh, by the way, Chris finally joined us. I don't know how long he's been there.
Yeah.
But
yeah.
Was that on the stereo imaging? Was that on the stereo imaging that we saw the moon?
Sorry.
We saw the moon whip around the sun. Was that stereo?
It was core 2B.
Oh, behind. Okay, that's right.
Yeah, it's core 2 behind, February 20th, 2007.
Okay, I just had the wrong. Yeah. I have the dates because I'm going to pull it up so everybody can see it. Christopher, what's happening, my man?
Not much.
There you go, buddy. What's happening?
I'm just driving, going home, gonna connect at home. Not much. I heard about. I can't talk. I heard about a letter. I heard about a letter.
Oh yes.
Did you guys already talk about that?
Yeah, we had a live stream about that.
Okay. All right. Cool.
Yeah. Yes. They decided to censor me. But the word censor, we actually thought was, at least when I first read it to Scott, he thought it was censor, but it actually censor. In other words,
It's spelled differently.
Well.
C-E-N-S-U-R-E, C-E-N-S-U-R-E, censure.
It's C-E-N-S-U-R-E.
Yeah, censure.
Yeah. So basically, they want to punish me or something like that. Make me feel bad about what I did. Yeah.
But they can't stop you. But they can't stop you from putting out.
So it actually means express severe disapproval. So this is what the dean did. He was expressing his disapproval of what I have been doing.
I had a subscriber write to me.
Yes.
That's an attorney. And he said they can't do a dang thing to you. So from what he read, now I could be wrong, and we still don't know. Okay. But they just look upset. Mm-hmm. They can't do anything, and that's it.
Yeah.
I don't know what you guys have talked about, and sorry I kind of joined late, but I figured I would add my own 2 cents. Because he was really standing by that. I should forward it to you. You guys went through the last presentation. That's awesome. You guys have been on for a while, over an hour, yeah?
Yeah, I think.
Something like that, yeah.
Okay.
Claudia, why don't you
go ahead, please.
fill Chris in on the newest WSO development?
Please.
Okay, so apparently Steve is actually blaming Scott and you for leaking my information and getting me fired. So
what a fucking idiot! Oh, sorry. Wow, I can't believe he said that. Okay, go ahead. Sorry.
I know. So I actually had to explain why I had to stop working with Steve. Because I believe he was the one who leaked my information. And why I've had this kind of trouble. And so I had to explain what happened. I had to explain that, you know, you was always so careful because there was metadata on my document and you would never show it to anybody. But Steve was never careful. Yeah, and was never careful. In fact, he was so careless that he spread my documents out to other people. So
they were contacting you way before this whole trolling situation, and they were able to locate you because of the metadata embedded in the PDF document.
That's right.
What an idiot. What an idiot.
Yeah, so I had to explain. Also, I had to explain that I was sending him my work and my articles, and he was refusing to make videos on them. You were basically the only one making videos.
That's right.
And the trolls were attacking you, and no one else was putting out that work. And I figured I needed to find someone else to help us. And that's when Scott came in. So this idea that Steve actually can say that you two are to blame is completely ridiculous.
That's
and
right.
I was never going to say anything about Steve because I still had some respect for him. Notice that I say I had.
Yes.
But after he comes out with stories like this, I'm sorry, but I think I've lost the little respect that I had left.
Well, I hate to say
and
go ahead. You go. Go ahead. Sorry.
Yeah, so this is why I had to set the record straight and explain what really happened. And I'm sure people noticed that I stopped working with Steve. And this is the reason why I did not feel safe working with him anymore, because I believe he leaked my information. And it got to the point where I even thought that he may have done it on purpose, although I cannot be sure of that. And I'd like to add that although I was never upset with Wayne, I worked with Wayne as well, and he was always very respectful and very nice to me. I had to stop working with both of them because they were working together.
Well, I hate to say it, but one of my first impressions about WSO was not good. So I'm not going to get into it now. Anyway, well, thank you for telling me about that. I'm really upset.
Oh, we got into it. We got into it real good in the beginning of this live stream because after our early morning live stream,
okay,
within 5 minutes, I got an email again from him, basically accusing us of perpetrating a fraud based on her termination at the university. And
that's not true either, because
trying to explain the whole entire process after she was basically relieved of her duties. That's the beginning process, and then she got her union representative involved. They got involved with the university. So now there are other steps and other measures that they're taking, like trying to force her into retirement, trying to do this, trying to do that. And now this email comes from the second highest at the university. You know, I mean, of all people to talk about gathering donations and contributions for her legal fees here in the United States against Astronomy Live's slanderous defamation has nothing to do with what's going on in her homeland. And of all people to talk about taking donations and contributions, listen, don't even get me started. If you want to take over from this point, you can. because I'm fired up.
I know. Man, I agree. Look, I lost respect for WSO when I was accused of me and the physicist getting a little bit kinky together, which never happened. So I thought that was pretty funny that he would have accused me of that and her. I thought that was pretty putrid. But to set the record straight, I'm the only mofo until Scott came around that had any desire to protect the physicist, her identity, and the work that she was doing. And everybody else besides you and I have done a horrible job. And that's all there is to it. So I'm grateful that things are starting to move along from a legal perspective, I guess, from her school, because I've been very concerned about that and still am. We don't know what the eventual outcome will be, but at the beginning it didn't appear to be very positive. So, you know, we've had to lean on what we understood to be the case, and we've made comments accordingly. We still don't know, but as far as we know, you're legally employed on paper. And that's all we know so far. Hopefully they don't let you go.
Yeah.
They put you in retirement or sabbatical or whatever. It's going to be very apparent that they just don't want to deal with it, and they'll just retire you. And we're hoping that that doesn't happen. But if any of that happens, we already know who to go to for the blame, and it has nothing to do with me and Scott at all. And the trolls and everybody else knows it, and they can't lie. Don't lie, people. Come on. Come on. Stop lying, man. We can see it from a mile away. It's ridiculous. So anyway, that's all I have to say for the moment.
Okay, thanks, Chris.
You know, I mean, if you think back to the very beginning, his YouTube channel was infiltrated twice by a female and then a male, and then who is now living together in Buffalo, New York, with their own YouTube channel, trolling away. And then who was just in their live stream the other night, kissing their rear ends and telling, what's his name? Oh, you have such a beautiful voice. I love listening to your music videos on your personal YouTube channel. Daz the cameraman's in there. I mean, I have all the screenshots. They made me absolutely sick. And then you're going to email me with that type of trash. I don't think so. You're barking up the wrong tree.
I agree. Well, it's disheartening to hear that some of these folks have started to act because of the situation, but I'm holding firm to the fact that I've done everything I could to keep the anonymous, or the physicist anonymous, and to keep this stuff coming, because I really feel like we're onto something significant, and I don't see anybody else on YouTube that's has the guts to attack it in any way, and those of us that do get attacked. So,
oh, the newest rumors, they started to spread. The last few days that I was very, very busy with other matters, they immediately started the rumor this morning that I was taken into custody, in jail, and I was waiting on being bonded out. But yet I was, answering emails, answering comments, and was putting up the 3D live stream and communicating with people during the live stream of the 3D earthquake tracker. But they gave me that privilege in the lockup because of who I am. Thank you very much.
Wow. Is it because you haven't made videos for a few days? Maybe they were just spreading a rumor.
Yeah, exactly. And I told everybody that, I had some personal business to take care of with the dealings with my grandmother's house and furniture and moving and things of that nature. And I also do have a little bit of a life left outside of YouTube. It's little, but I still have one.
Good.
And I wasn't taken into custody. Not yet.
Yeah.
But Chris, can you see what we're showing? Can you see what we're showing on your screen?
Yeah, that's isn't that the Deb Blue footage from 2007?
Yeah.
Yeah, I've got it memorized.
Yeah.
Because wait, it's the moon. It's the moon. It's the moon.
Or
yes, that's what they said.
It also could be identified as the flying cheese sandwich.
That's right, baby. That's right.
Well, guess what? That flying cheese sandwich is making its way around the sun at a very, very rapid pace over the course of a couple of days. And you can see the timer, the date stamp, everything right there in front of you, ladies and gentlemen. This is right on the stereo website from NASA behind Core 2, and this is 2007. So this tells you how long ago this or these activities have been going on in our inner solar system.
That's right. So if when you watch this image very carefully, it's not always obvious, but the object glows when it's glowing from one side, like you saw in the image I showed in the document. It glows on one side when it's close to the bottom of the image, and as it approaches the sun, it gets darker and darker. So it's so amazing to watch for me, because I can see that it's energy mode. It goes from energy emission mode, that's when it's glowing, to energy absorption mode. That's why I can say that these objects are absorbing energy from the sun. It's obvious. Why would an object do that? I mean, and it was glowing on the side that was away from the sun, the side that's facing the camera, actually more on the right-hand side. And it was glowing on the side away from the sun. So it's got to be a plasma reaction in the object, well, actually in the envelope, in the gaseous envelope, ionized gaseous envelope. So it was a plasma discharge in the envelope. It's obvious. And yet it just decreases as the object moves towards the sun. And from that, I mean, what else can I say? You can see these objects absorb energy from the sun. And it's not just plasma that they absorb potential energy. This is what we see in this footage. Because stars have potential energy, and now we see that these brown dwarf stars are able to absorb plasma like white dwarf stars. And it seems that they can absorb electrical potential energy, which they then use to power their own system, so that they start having plasma discharges. Eventually, they get the plasma from the sun, and notice, because they have high electrical potential energy, they can restart a process of cold fusion from their surfaces. That's why they don't have to be that hot to do that. The cold fusion process then will produce heat and light.
You know,
and I believe that's what happens on the sun too.
Look at the size of the damn thing. I mean,
it's huge compared to the size of the sun.
The moon would look like a little tiny dot.
Yeah.
Compared to the size of this object, and the speed.
Yes.
The speed of this object, and it seems like it almost gains speed on its exodus out of the sun, from away from the sun at that point.
You never see the moon having this kind of orbit. It's ridiculous. Look at it. It's elliptical up towards the sun and then out. And then what else happens? You can actually see the object in the HIB images. It moves it moves away from the sun like the other planets in those images, except it's smaller. I actually have some articles on that. And so, I mean, it's ridiculous that they think it's, and then you actually can see it when it traverses the sun in the other images.
Because we
difference.
caught it on other cameras.
That's right.
Yeah, 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 most definitely.
And could see that the corona, it was inside the corona, because you can see ultraviolet light in front of the object. The only way that could be possible was if the object was inside the sun's corona. This is how close it traversed the sun. It went right inside the sun's corona. And that's why I could estimate its size. And it's 1.7 times the size of Jupiter. In other words, nearly twice the size of Jupiter.
But Astronomy Live in
And look at this.
they say it's the moon, so it has to be the damn moon. So
yeah, and you could see that the sun's reaction. Look at what the sun is doing. It's actually like it's having a huge plasma. It's not plasma. It's like what
it has a reaction to.
It has a reaction.
It has a huge reaction.
So for anybody, for a naysayer to say that that's the moon or anything but we think it is, they're scared.
Yeah.
They don't want to admit it. And the moon is a very comfortable answer.
That's right. Well, they're trying to keep this information away from people who would do something with it, like I am doing something with it. And look how the sun goes dark below that. We just, that was the reaction. So they don't want us to know what's going on. That's these trolls' jobs. They are paid to keep this information away from the mainstream, from the world. There goes the object again. This is in the core one. Yeah, and you can see the reaction from the sun as well. Yeah, and so they don't want us to know because it rewrites everything. Yeah,
that's right. Didn't you and I coin the phrase "the physicist's thoughts"?
Yes, that's true. We did. Yeah.
Another one in your face. That. Another in your face, troll.
Oh, Lord.
I just that's called a cat call. If you ever heard, let me do another one.
Look at the size of that.
Sorry.
Okay. Yeah, it's huge. And look at the reaction from the sun, how it goes dark.
He freaks out a little bit.
It does. I mean, why would the sun react like that to the moon? You tell me.
Very true. So in the last picture, so this is core 2B behind, when the behind was still around, or no? This is
B. This is core 1B.
Yeah.
Oh, okay. Core 1B. Okay.
Yeah.
What I was going to say was in the last one that we were looking at, it was in red. Maybe that was core A.
That was core 2B.
Oh, core 2B. On the occulting disc was like a flat winged like structure at the bottom. Why? Is that another thing to hide stuff?
I believe that they do that to hide stuff.
And
I haven't gone into it very. Yeah, it's like a cutoff line.
Okay, because I noticed, like, I'm putting together a new subscriber video because I complained and wasn't getting any footage, and then folks started sending me a bunch of cool footage, and I have a bunch of core 2A and B stuff, whatever. Anyway, every one of the images is cut off. Every single one. And you have to think that that's suspect to use cutoff lines in any way. And then the goes where the friggin' thing moves, the cutoff lines, there's two of them moving. Look at that thing. That's not the moon. That's not the moon. He's huge.
But you have to remember something. You have to remember something. The people, the two individuals that made these comments and these observations that this is the moon, there's one key word, and they call themselves this. They're amateurs. They're not professionals. They're not professionals. The one doesn't hold any degrees whatsoever. The other one holds some degrees in like customer service or something like that. That's about it.
Underwater basket weaving. It's
there you go.
But no, for real, you guys. If you look at that thing, it's huge, going by the sun. It goes by fast. I'm an amateur puke too, and I don't know what I'm looking at, but it doesn't look right to me because I don't remember a planet doing that.
Yep, most definitely.
Especially making the sun go dark.
Yeah.
I thought the sun's around to go dark. That's not right. It's not supposed to do that. You can see it's reacting to this object.
Mm-hmm. Yeah, I'm still very surprised that after all this time, I'm very surprised that this footage is still available. If it wasn't for Debbie Blue, who is a journalist actually, and she discovered this and she made this public through some videos on YouTube and uploading this to a website that she had developed. And at the time, back in this time, NASA did everything they could, and they took her website down. They took it down. They took it down. They took it down. They deleted the information, but she had it on saved video and she kept putting it up. Mm-hmm. So they didn't have any recourse but to, maybe create a cover story. And
whoa.
Yeah. Then I discovered it, and all hell broke loose in August of 2016 when I started putting this video footage up on YouTube.
Yeah.
And it was a magnet. It was the troll magnet. And they have
watch right now.
Yeah,
boom.
They've been on me ever since. And,
they love you, bro.
Oh yeah. Yeah. They're like my children.
You're like paying their bills, bro.
Yeah.
I'm serious. They get all of the love and views because of us. They wouldn't be around if it hadn't been for us. So we're paying their friggin' bills.
Yeah, they're not too happy with the new YouTube channel Troll Spray. They're very, very upset with this new channel. And they're crying and crying and crying because they are saying that I'm harassing them and I'm abusing them.
Oh, you little babies. Give me a break.
Yeah.
We're abusing you. Come on. Another lie.
I got the emails. I got the emails all weekend. I set a few of them straight by, talking the way that I do outside of a YouTube video.
Yeah.
I threw my professionalism into the trash so they fully understood what I'll do to them. And just like Tony Matthews over there at Factor Fiction, he wants to start throwing his mouth into the game. Well, I'm going to put Tony Matthews on blast first thing tomorrow morning. And anybody else that wants to step into my arena, I'm going to put you on blast on YouTube my way. So if you continue to harass me or Chris Potter or the Physicist, I'm just going to put your stuff right out there. And I know how to do it the right way to follow the YouTube policy, and the video won't be pulled. Because as you can see, you blithering idiots, if you go to the new Troll Spray channel, all 30 of the privacy and policy strikes that you idiots put against me 4 days ago, well, they all failed. And all of the videos are still up there. And they look good.
They do look good. They're little juicy little videos. Good job. Gots to have me some stroll.
So here's the thing. It's a little tit for tat. If you do it to me, well, I'm going to do it to you back. I'm not like the other YouTube channels. I don't bow my head, put my tail between my legs, and run from you guys. I actually seek you out because I like to destroy you, because you deserve to be destroyed. Do you hear me? Each and every one of you need to be destroyed. Period. You're not doing the world any good.
Where we had to troll the trolls because they wouldn't leave us alone. So
people have that saying, "Don't feed the trolls." I don't feed them; I eat them.
I like that's a good one. That's a good advertiser-friendly.
Hey, Jeff P. Jeff P's in the chat room. Jeff, would you like to? Jeff P. Would you like to jump on board? I could email you the link real quick. Just give me a big yes or no.
And trolls, leave him alone or you're toast. Leave my Jeff alone. I almost went and visited him last year in Sacramento. We almost powwowed. The poor Gu is very busy. He puts out good stuff. Jeff's a good dude.
Yeah, Jeff is, I'm going to email him our link real quick. Hold on 1 second.
Yeah, that's cool. We'll just, hang out and chat for a bit. We don't normally get to have these big, long hangouts, and we haven't had one for a bit that I've been on and said much. So, not that I have anything spectacular to say.
You guys go ahead and discuss
something. Okay, we'll discuss something.
Tit for tat.
Yeah, well, there was one other thing that maybe I should mention, and that is, I read the letter from the Dean of the Faculty of Science, and they mention a lot about my teaching students.
Yes.
Now, I never actually taught my students about brown dwarfs or anything like that, but what I did do was I taught my students to keep an open mind regarding the accepted theories. In other words, I taught them to question accepted theories, which I taught them the accepted theories, like the curriculum says, but specifically these are theories. And sometimes I would mention certain things like questions about certain things. And then what they did, so this comes from the victimization that they've done against me. They have forced me to change the textbook to one where I cannot do that. And they've given me slides to use, so I cannot actually, I basically lost my voice. I was not able to lecture like I used to. And my students loved my lectures. So this is one of the things they have done to me, because they don't want me to teach my students to question accepted theory. And that basically comes out in that letter. That's why they mention so much my teaching students and my teaching the curriculum. So I always taught the curriculum. I just taught my students to think. And that's what was happening.
I noticed that too. That they didn't.
Yeah.
They mentioned that they were concerned about you teaching some of that to your students, and they really emphasized that they didn't want you to do that.
That's right. So basically,
go ahead.
Yeah. So basically, they are trying to block me from teaching the way that I would normally teach. I mean, what they did to me is never done. You never dictate to a lecturer what textbook they are supposed to use. And yet that was done to me, because lecturers are supposed to be able to choose what textbook to use. It never works to force them to use a textbook they don't want to use. And in fact, that was done to me. So as you can see, the victimization has been going on for quite a while. Well, it's happened this year, and when Astronomy Live sent that letter, basically that was it. They may have even seen that as a way of possibly getting rid of me. And to tell you the truth, after all that I've been through, because I want to teach my students the way I think they should be taught, because I want to give them an open mind and be able to think of theories as actually theories and not fact. I don't actually feel like lecturing at the university anymore. So I have to add that from the time that this happened, I could not see how I could go back into the department. I mean, I still go into my office now and then because I have things to do there. Mm-hmm. But I don't feel comfortable inside that building because I feel like I've been pushed out. So that's a few of the things that I wanted to add.
Yeah, that's a hostile work environment right there.
It is, definitely is.
Chris, have you heard anything about what's going on in the Sierra Nevadas? I'm getting all kinds of reports about the water runoff and the melt up there in the mountains.
You know, my mom was letting me know that there had lots of reports in the state that she's in. That's in the Sierra Nevadas, that they're really concerned about the amount of runoff. That's all I've heard. I haven't looked at anything else. All I know is that some of the channels on YouTube you and I both follow had mentioned something, like BP Earthwatch, Storm News, some of these guys have been letting us know to keep an eye on the runoff, that they're very concerned with the amount of water that will come out because of the runoff. Yeah,
that's a lot, man. I mean, didn't it? I could have I swear to God, I just saw a report that that they got more snow, a spring blizzard.
Mm-hmm. Yeah, they're very concerned with the amount of runoff that's taken place this year. Oh, and there was a small earthquake at Oroville Dam.
Yeah, they were saying that. They were saying the other day that, excuse me, that earthquake was listed as an explosion.
Okay.
As an explosion, 500 feet below the surface, not an earthquake. What in the hell would they be doing 500 feet under the dam using explosives?
Who knows, bro? Who knows? We know that there's underground bases all over the place. As far as I'm concerned, they don't want that dam to blow. Who knows? Maybe they bored some tunnel underneath it and started looking at it. I mean, I don't know, but that doesn't even sound right. Because why would you want to play around with the infrastructure of the dam by digging underneath it? That doesn't sound right either. So
no, because you would flood the tunnel, whatever you have there. I mean, there's a danger of flooding it because you have a dam right over above.
Exactly. Yeah, so
why would you even build a base there? I mean, it's crazy.
Yeah, okay.
Yeah, that's crazy.
Good. Well, then there you go. So it couldn't be either. To me, my first impression was something big broke really deep underneath the dam, and that was what was triggered.
Yeah, it was first listed as a chemical explosion. And I guess if you're using plastic explosives, that would be a chemical explosion. What the hell? I mean, what the hell are they trying to do, man? That would, I mean, come on. That would.
Oh, I see that you are inferring that they're trying to create the flood. They're trying to break the dam.
Yeah, because it's
make it break and flood. Okay, God, I didn't even think of that. That was what they were saying about Hoover Dam. That Hoover Dam was going to go.
Oh, dear God.
Who knows? I mean, right? And that was what, last year when they were doing it, and they had a weird lamb or sheep laser show on the dam itself. It was really weird and symbolic. Come on, man. What are you people doing? Yeah, so we don't know. I mean, if they're messing with the dams, it probably has to be to break them, to cause a natural disaster, to necessitate a law that needs to be passed that they couldn't pass any other way other than a natural disaster happen. So they create the problem and necessitate the solution. It's the Hegelian dialect. They've been doing it for thousands of years, right? So you cause the problem and necessitate the solution. It wouldn't surprise me to drop a little bomb underneath one of these dams and make the sucker go. And then, of course, from a terrorist point of view, well, absolutely, we should be worried about that. We don't want no terrorists blowing up our dams because so many people die, right, from the flooding. And I mentioned this before for Oroville Dam, Had the dam broke, they said that downtown Sacramento would have crested at 30 feet underwater within a minute or two. So people would just be dead. You're not going to survive no 30 feet wall of water with all the trees and infrastructure, cars, you know, going with it, right? So, yeah. But see, that's another example of why social media is so powerful, and we should keep an eye on little stories like that. Because sometimes these little stories from here and there and everywhere kind of interconnect, and they're very valid. So like in your YouTube subscription feed, when you start seeing similar stories from your other, you know, the channels that you watch, that's suspect. Anyway, I went off on that for a second, but yeah, I pay attention to all those little details because we don't know.
Yeah,
yep, most definitely.
I think you're right.
You know what? Hold on one second. Hey, Jeff, if you could hear me, I sent you the link to your 777 email address. This is the live stream link. It's in your 777 email address. I think it's your Yahoo address, if you could hear me.
Hey, wasn't it one of the trolls that said that they were going to beat you up in an MMA style fight, Scott? And then we found out that there's some 300-pound Rolo.
Yeah, Tony Matthews.
Okay, thank you. Just wanted to verify that.
Yeah, that's okay. I got 15 years of Brazilian Jiu-Jitsu under my belt. I'll take that challenge any day.
Oh, I love it.
Any day.
I just have to say that.
I trained 15 years at the Gracie Jiu-Jitsu studio in Miami, Florida.
Gracie is a well-known and highly respected family studio. How do I say it? A group of studios, the Gracie family. Well, most of those folks are badasses, man.
Yeah, they developed Brazilian Jiu-Jitsu.
Oh, okay, yeah. So Gracie is like UFC and Gracie. The two don't, as far as I'm concerned, aren't disconnected. You hear the two all the time. Yep. So they're a very well-known family, and the teaching, from what I've seen, because I watch a lot of UFC. Wow, you don't want to mess with some of these people. You could really get yourself literally hurt or killed. But Gracie, the style of schooling I've seen because yeah, I watch this stuff quite a bit. Their schooling is awesome, and it's male or female. It doesn't matter. Yep. These girls are kicking butt too.
Oh yeah, they're
anyway, Gracie. That's pretty interesting. I didn't know it was the Gracie school you went to. They're very reputable.
Yeah, they opened up the. It was one of the sons, and I actually sparred and learned from their father, Hoist Gracie, and yeah, all of them, man. I met them all in 15 years, man. 15 years at their studio, and yeah, I would love that challenge. I would take that challenge up any day.
I was thinking that you would, and I figured I just wanted to verbalize it very publicly, just to kind of put it out there, just lay it thick, baby. Oh.
But we know we know those buff photographs of Tony Matthews were fake. Those were a gay porn star that he used. So we know those you know, those buff photographs of that well-built gay porn actor. That's not him. From what I understand, he is fat, overweight, wears pop bottle thick glasses, and still lives with his mother.
I love it.
Yeah, so I'll take that challenge. I'll take that challenge any day, any day, any day.
I just had to put it out there because I
mean, one of the first techniques I learned was the rear naked choke, and I perfected that baby, and I have elbows that are like stilettos.
So the rear naked choke is if you get someone in a rear naked choke, they're not going to get out. They're going to tap out. You're going to knock them out.
They ain't going to tap out.
Actually kill somebody.
Yeah,
they'll just knock out. Right?
My arms are just the perfect stature to slip underneath there. And I would say if you're in excellent shape and you could probably hold your breath, I'd give you about 7 seconds. If you're like Tony Matthews over there, fat and out of shape, I'll probably give you about 3 to 4 seconds, and you'll be peeing your pants.
Okay. Yeah, that seems about right. Your elbows from the little bit of UFC study that I've done, are some of the most powerful weapons that you have in a fight, and your knees.
Oh, my elbows, man! I'll tell you what. Some of the training that they put you through to toughen up your elbows. Now, nowadays and through my late 20s and my early 30s, it just became a natural reflex and a natural instinct to react. And yeah, it's got me into some trouble here and there, but it was all for a good cause. But yeah, I mean, it's very good to learn. You know, I enrolled my son and my daughter both. Yeah, my little girl didn't like it too much because she was like real prissy, but my son enjoyed it, and it produces a very good discipline in young kids.
Totally. My son's in judo, and we live by it. We stand by it. It's really perfect for him for discipline, and I want him to be able to defend himself. So yeah, no, I think that's cool.
Oh, absolutely, man. And the judo throw, I learned the judo throw. It's just, I mean, you know, anybody attacks you from behind, hey man, bingo, the judo throw, boom, hip toss, you're on your back. You know, you're on your back. And if you're on your back, you're already stunned. What the hell just happened to me? And then, you know, if you know what you're doing, strike, 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 you're out. See ya. Goodbye.
Wow.
I'll be walking down the street to go have a coffee while you're laying in your own piss.
Unfortunately, it happens. I've watched enough fights that, yeah, folks do that. Is Jeff going to join us?
Yeah, I sent him the email to both of his email addresses. He was actually trying to join a regular hangout conference.
Oh, okay.
Yeah, so I emailed it to him, and
so did you guys do 2 today?
Yes.
Oh, yeah. So I've been.
Yeah, we did one early this morning. That was based on the letter and information. And right after we finished that live stream, lo and behold, a lawyer from her home country emailed me. Very nice man. And
really?
Yes, he did, man. And he is a very good lawyer. He's going to be getting in touch with her, and they're going to meet, and he's going to see if he could help her out down there.
Ooh. Yeah. I just had to turn on my camera to say that too. Ooh. All of it. I love it. You know, because seriously, we need some justice here for this young lady.
Yeah, I would have to agree.
Started this whole friggin' mess by flapping his gums and then lying about it. And the rest of his group lied for him too. You were mad because he corrected you. No, because he talked smack. And then he went after a job, and now where we are right now is where we are. And we got lawyers talking to us. Yeah, you know, people thought we were full of it. But it looks like the tide is turning. I love it. I had the attorney guy email me today. I was like, whoa, dude, what's up? I thought I was getting sued. I'm like, okay, who's suing me? Right? So anyway, yeah, we have folks that are very interested in what's happening in the behind the scenes because the physicist has been dealt a bad hand. Now I'll turn off my camera.
Yeah, I agree, man. It's I mean, that just goes to show you, though, if the information wasn't valuable, that's the word I'm going to use. If the information wasn't valuable and it was nonsense, then why go through all the trouble?
You're right. That's what I was saying the other day on my little mini rant was why? What? Why? What's the problem? What's the problem? Does it hurt, babies? Huh? Are we sharing the truth and it hurts? Oh, I'm sorry. Do you need to go back to your henchman or your controlman or what are they called? Your handler? Yeah, and tell them to piss off because we can't get Chris and Scott shut down? Well, good. I hope you get fired from your job there, you troll. Because it does hurt. Because we are not going to shut up, and what we're sharing isn't BS. That was not the moon going by and the Dev Blue footage, and we should all be very concerned about what that little guy is. And we should be collaborating and trying to figure it out, friendly, kind, and loving. But we're beyond that point. And if the trolls ever try to come to us, even when things start hitting the fan and go, oh, we want to help. No, you're not going to help. You showed your true colors last time. We don't trust you. So it is going to come to a point where these people are going to be having their tail between their legs, or they're just not going to say anything and evaporate because they were wrong the whole time. And their job to harass us, well, when things start hitting the fan, you're not going to be able to harass us anymore because you're going to have to, you know, figure out and fend for your own. What are we going to do then? I mean, seriously. So I think folks are going to think a lot differently when the weather starts freaking out more. Look, we can all sit there and go, the brown dwarf is BS, Jesus is BS, the second coming, all of it's BS. But you cannot discount the fact that we're having serious weather anomalies. And that's it. And they're kicking up every year, worse and worse and worse. So you've got to, okay, you have to stand back and go, okay, what is happening? It can't just be, oh, the Earth goes through every couple hundred years, it goes through this little cycle. And it's just a little bit of extra weather. No, no, no. That is not what's happening. We have unprecedented levels of rain, hail, earthquakes, volcanoes, sinkholes, and then not to mention everything that we're trying to look at from the magnetosphere, the jet stream. And yeah, we might not be right about everything, but it don't look right. And it hasn't been looking right from the time that we, even as kids, sorry I'm going off for a second, but let's say, okay, we're just a kid watching TV. I'm 44. 30 years ago, I'm watching CNN. I don't remember the storms being this nuts. Do you? No, I don't. They're going nuts. And I'm going nuts right now, talking about it going nuts, because it's obviously increasing every year. So what is it? What's doing it? And if people are looking at the solar system and they're saying things like, well, all the planets are bowing, something's affecting all of the planets within our inner solar system, that's suspect. There's something being here, and it looks like he was here before. So I think for any of us to discount the weather anomalies is to be irresponsible and is to be a naysayer illegitimately. You should really pay attention to what's happening, because our crops, especially here in California, that provides food for like 80% of the friggin' planet for fresh food, for fruits and vegetables, we should reconsider when these hailstorms come and kill our crops, and we can't produce as a nation, as a world, and we've got to rely on our food storage. Yeah, things are going to get that bad. They're going to get that bad that we're going to have to rely on each other. So unfortunately, you trolls, I'm just going to tell you, we're never going to work with you. I'm sorry. There's one thing to forgive you, but you guys are beyond forgiveness. You're not trustworthy. So unfortunately, when the ship's going down, I'm kicking you out of the ship. I'm taking your freaking life vest, and you're going to drown. That's all there is to it, because you ain't needed. You were never needed. You folks are a distraction. You're a problem. And that's it. There's my rant. Thanks for listening. I don't normally rant, but I
said it any better myself.
Seriously, Scott. Dude, I can't sleep at night sometimes because of this crap. And for these people that are harassing us the way they are, like when you died and you didn't, dude, we thought you were dead, dude. And for these people that have done that, I'm not going to get emotional. It really makes me angry that they would be messing with us like that. It's not cool. And all I know is I'm glad that there is our Father in heaven, because he is going to make it right in the end, boo. All right, I'll chill for a minute. Thanks for letting me rant.
Yeah, I'm trying to get Jeff the link. Jeff, if you're listening, click on the link in the Hangout.
Click on the link, boo. I know, hey. And Jeff, exactly. And Jeff, don't feel bad if you click on the link and all of a sudden your computer crashes. Something weird. Oh, hello.
You know, when
hello?
I sent that letter, basically.
We hear you. We see you.
They may have even seen that as a way of possibly getting rid of me. And to tell you the truth, at the moment,
you hear that, Scott?
I want to teach my students the way I think they should be taught, because I want.
Scott?
Yep. Yeah, I just had to eject this idiot.
How did they get in there?
Because I had to put the link in the live chat because Jeff couldn't get it out of his email. I don't know what's happening there.
You shouldn't have done that, dude.
Oh, it's all right. I could eject them as fast as they come.
Oh, okay, okay. So I was curious I had a feeling that some idiot joined.
That's exactly what they are. Idiots.
Can I ask, let me word this correctly. Do you still have a certain helper around, Scott?
Yeah.
Okay.
Yeah.
Okay.
I don't know how Jeff can't get.
Oh, but the trolls can. Yeah. You mofos. Oh, I can't wait to meet some of these people on the other side.
I know, right?
I'm serious, because seriously, I think about this often. I'm like, okay, if we're eternal beings, we have bodies. Okay, we have spirits, we have bodies. We had to come to Earth to have our bodies tested. We die, we're spirits, then we get resurrected, then we're eternal. Well, we're talking smack about me on Earth. Let's talk about that now. Me and you, Boo, in our resurrected bodies. And let's see how we wrestle in our resurrected bodies. Let's go ahead and talk about it now. Because you're the first out of about 1,000 people that I need to talk to.
Yeah, right?
Yeah. Oh, yeah, dude. I'm going to be running around in heaven. Okay, who? Wait. Where's Tony Matthews? Well, I got to see you, Boo. We got a conversation to talk about. Ow!
Oh, if anything ever happens to me, and you know, I fully believe in the life hereafter, and yeah. I know my spirit life is staying right here, and believe me, believe you me, I will be the ghost at the bottom of your bed, causing you to piss your pants when you wake up of sheer fright as I'm standing over top of you.
Scott's gonna come back and haunt you, dude.
Oh, believe me, I've told them that before. You know, besides barbecuing them with the sweet Baby Ray's barbecue sauce, I will come back if anything happens to me from now till whenever. There is absolutely no doubt I am coming back, and I will personally, you know, hunt them down in my spirit life, and I will terrorize every waking moment of their existence.
I love it. You'll even poltergeist them.
Oh, yes, absolutely. Really absolutely. Every member of their family, too.
Wow.
Absolutely.
You know, it sucks that we feel this way, but we do, because we've been so harassed, and we want things to be equal and fair, and I'm grateful that our Creator will eventually do that.
Hey, you know, I mean, it is what it is. You know, they put themselves into, you know, that arena. So it's my arena. You know, they want to jump into it. Then, you know, whenever I bash them, then, hey, you know, but they cry. What are you doing that to me for? Look, Scott's crazy. Chris is crazy.
Yeah, right. Chris is crazy. You want to see how crazy I am?
I was say that. Meet me on the street, you know, and this real nice, lovable, professional guy that you're listening to now, well, yeah, I'll just throw that shit right out the door. You know, because I could go ghetto. Same. I could go ghetto real fast.
Oh, I have to. Okay, I'm going to admit something to you. You know, the one neighbor, the one neighbor I told you about in their certain door?
Yeah.
That was me. Yeah, it was me.
Oh, Lord.
I couldn't tell you. I was embarrassed, dude. But it was me. I was so, yeah. Well, I'll have to tell you after the live hangout, because when you laughed, when I first told you, I thought you figured it out that it was me. So I just kept going with it, and I'm like, I'm not going to tell him. I'll tell him later.
That's hilarious.
I knew you.
Well, what we're going to do is probably tomorrow. The doctor, she's working on another paper, and what we can do, based on your schedule, maybe perfect. Sometime late tomorrow morning, we can jump on here and get that.
I'm available the next 3 days. That's fine.
All right, that's cool. That's cool. I'm gonna run. I'm gonna shut this baby down. I'm gonna run. Okay. I got some things to take care of, and then maybe later on, whenever I got some time, early evening, I'm gonna put Fact or Fiction on blast.
Good.
On the Troll Spray Network. See how they like it. I have a few others that I'm going to put on there also.
Okay, sounds good.
Yeah, there may be another YouTube channel that may get a debut on Troll Spray.
Oh, that's awesome.
Because that Troll Spray, it's lethal, man. Double dose of that, you're down. All right, there, doctor, our professor of physics. You have a good evening. Both of you have a good evening. Everybody, thank you very much for joining us. And we'll be back here tomorrow. And make sure that you are fully subscribed, your notifications set up to Chris Potter and the Nibiru channel and Planet X News. And, hopefully we're definitely looking at some increased earthquake activity this week. There's been a couple of reports out there. So, ladies and gentlemen, if you live in any of these areas where there is a lot of earthquake activity, whether it's in the United States or Indonesia, please keep yourself fully aware of what's going on. God bless all of you. Hopefully nothing happens, but the possibilities this week of some high magnitude 5s, 6s, and possibly 7s are definitely on the plate. So please, everyone, make sure you stay safe, and we will definitely see you again. So make sure you stay tuned. Take care, everybody.